Station, this is Houston. Are you ready for the event?
We are ready for the event.
We are ready for the event.
Ready for the event.
Fox News Radio, this is Mission Control Houston. Please call station for a voice check.
Station, this is Fox News Radio and Eben Brown. How do you hear me?
Fox News Radio. Evan, we hear you loud and clear. Welcome on board station.
Thank you so much. It is great to be back and speaking with you, and it's been a while, but we're so glad to see your faces again. The first question I have for you is probably the big news, and although we've encountered another delay here, we're getting very close to seeing this test launch of the SpaceX Dragon. This has to be something very exciting for the both of you up there, and as well as your crewmates. What do you think a successful test flight means to you and your crewmates?
Well, a successful test flight means everything happens according to plan, where the vehicle gets launched, it rendezvous with station, all the commanding goes as what we'd like from the demonstration point of view, where it comes close to station, then we send it away, then it comes back, and then we snag it with the robotic arm and berth it and get the supplies off. And then it doesn't end there. We load it up with payload to go back to Earth, and then we unberth it and release it, and then it makes its journey back to Earth for splashdown in the ocean and recovery of payload. And this will be, if all of that happens according to plan, it will be great to have significant payload down capability once again, because everybody talks about getting payload up to station, but one of the things that's sorely missing in the wake of the shuttle retirement is getting payload back down. And we have all kinds of useful things that we want to get back down to Earth, but currently don't really have a way to get them down.
And Dr. Pettit and also Dr. Kuipers, you can answer this as well. A good number of the programs aboard the space station relied so much on shuttle. Would a good, successful test flight and eventual regular use of the SpaceX craft as well as some of the other COTS crafts, would this restore some independence to NASA in terms of its ability to get not just people, but as you said, the payloads, the things up and down?
Certainly it will restore some measure of independence, but let me explain something that's really going to be important in terms of the down mass. Currently, we have no way to get our frozen samples back, and crucial to the life science experiments that we are doing on space station, particularly the human physiology experiments. We have blood and urine and spit samples. We have all these things frozen in our freezers. We have 3 freezers on station, actually 5 freezers for samples, and they're down at minus 95 to minus 98 centigrade. And these samples have to remain frozen all the way to the laboratory from where they're going to be analyzed. And currently, Dragon will be the only way that we can get these samples back to Earth, and that will allow the science behind all our human physiology to continue.
No, that's okay.
You spoke much about the payloads, but also yourselves will be traveling in these types of crafts. Are there any safety concerns about flying either to the station or back home in a private craft?
Well, for the time being, it's a cargo vehicle, although the windows are already there. But I'm sure if things go well, the future will bring us also manned space flight with this kind of craft. And safety is a very important factor in space flight. We all know that, and I'm pretty sure that this will be the future of space flight as well. Besides all the things that the agencies do.
And I'd like to add that you look at the development of commercial aviation back in the 20s. And there were quite a few nasty little accidents that resulted in short-term setback, but then it set the whole aviation industry to a standstill. And I hope that that doesn't necessarily play itself out for space in our near future, but we shouldn't be surprised if we do see some catastrophes happen. And what we need to do when those do happen is just regroup, sharpen our pencils, figure out what went wrong, work on improved version, and keep going.
I'd like to ask you both about the historical sense of private space transit. You know, if you think back to the explorers like Christopher Columbus, who sailed taxpayer-funded vehicles across the Atlantic, eventually we had companies like the Dutch West Indies and other companies that did the work for the government. Are we sort of seeing the same thing now with space? Are we seeing a public-private partnership? And how does that make space more accessible for everyone else?
I think the settlement of the U.S. West is a good example of government driven but supported by commercial enterprises. And you see that with wagon train supporting forts, where the forts defined the government defined the mission that the forts did, but the wagon trains provided all the goods and services. And then you see that with the building of the railroads. The government didn't build the railroads. Commercial American free enterprise built the railroads at the encouragement of the government. And the benefits to these were immense in terms of the settlement of the western part of the United States. And I see this same type of structure going on in space, where governments will define the role, at least for the near future, and free enterprise will help supply the materials, the goods, and the services.
And it's been a while since we've had a big space story, because we don't follow the shuttle launches anymore, obviously, because there are no more. But how's the station holding up these days? And tell us some of the things you've been doing. And we know, Dr. Pettit, you've been working with Robonaut recently. So fill us in on what's new.
Well, from a payload science point of view, I've been working on some combustion experiments, which are really fascinating. Fire is one of the fundamental aspects that our whole civilization is built on. In fact, the human beings first using fire was one step that took us from where we were to where we are now. And it's not surprising that we are still scratching our heads and wondering how fire works, and we are studying how fire works in a weightless environment, where fire is hard-pressed to even burn in a weightless environment because you don't have buoyancy-driven convection. And so we have a series of experiments up here where we are burning both gas fuels and solid fuels, and looking at the parameters behind where they will burn and where they won't burn, and looking at some of the chemistry and the physics inside of the flame. So that's one of the exciting science projects that I'm working on. From an engineering point of view, we've been working on getting ready for Dragon. And this happens to be the control box for Dragon, where as Dragon is approaching space station, we will be able to push any number of these little buttons here to send commands to the vehicle, depending on whether we want to send it away or whether we want to put it into a mode where we can snag it with the arm. And working on this is engineering research. This is as good as it gets from the point of view of designing your spacecraft, making the systems work, and advancing the technology needed to continue the exploration of space.
Dr. Pettit, Dr. Kuiper, our time is running short with you guys. You have another interview coming up next, but thank you so much for your time. It's good to see your faces again, and enjoy your stay up there. We'll talk again soon. Have a great day.
It's always good to talk with you, Evan. You guys take care, and thanks for coming on board station.
Station, this is Houston ACR. That concludes the Fox News Radio portion of the event. Please stand by for a voice check from CBS News.
Station, this is Bill Harwood, CBS News down at the Kennedy Space Center. How do you read me?
We're reading you loud and clear.
Thank you very much, Andre. And Don, thanks for taking time out to chat. You guys obviously have a busy couple of weeks coming up. You got SpaceX hopefully arriving soon. You got the next Soyuz and all of that. Wondering how it's been going with just 3 guys on board, and are you ready for some company?
Well, actually, it's been very nice with 3 people on board. It's quiet. It seems like of course, there's a lot of less traffic in the station, and actually, it's a nice quiet time. So, but we missed the other ones, and we're looking forward to the new crew for sure.
Yeah, I can imagine that.
And I don't have to wait in line at the gym anymore.
I hear that. As you were just talking to the previous interview, we're all waiting for word from SpaceX on when they might be launching. What have you guys been doing training-wise to make sure you're ready to berth the Dragon capsule whenever it shows up?
We've been doing quite a bit of training, particularly oriented towards the crew role, which is flying the robotic arm and capturing the SpaceX vehicle when it gets in a holding pattern near space station, and then the arm will maneuver the Dragon vehicle to one of our docking ports, and then we'll fasten it to station, and then we can go about outfitting the vestibule and opening the hatch. And that whole process is going to be a long day for us. It's going to be 10 hours plus to get all of that done. And it may be, and if we have a few hitches in the way, we may have to put things on hold and pick it up the next day. So we've been practicing all phases of that part of working on Dragon.
Well, you raised one point. If they launch on May the 10th, which I guess is the only option now before Soyuz, it's not clear to me they'd have a second opportunity if there was a problem during the rendezvous. Is it your understanding if they launch on the 10th, it's a one and done, or would you have a second day that you could maybe loiter and still have a chance to dock it?
I don't know what the orbital dynamics are on that. I do know that there is a capability to send retreat commands and abort commands and then regroup and come back either in a few hours or a day or so. And I know we have that capability, and I'm not sure how all of this comes together with the May 10th launch date.
Tell me a little, you mentioned aborts. Tell me a little bit about what capability you guys have during the final stages of that rendezvous to make it go away if things aren't going well. I mean, I assume that's a command you guys send, or is that something Mission Control deals? Just kind of walk me through some of the abort capability you have all the way until you get to that 30-foot station keeping point.
Continuing with audio at this point, we'll need you on Space Ground 2.
Hey guys, I'm sorry. I think we had to you drop out. Let me.
And so we can push the continuing on with what I was saying. We can push the free drift command when we don't want any thrusters firing on the vehicle, and we do that right before we grab it with the arm. And then we have a depart command, and this is for a planned departure that we send the vehicle away when it's ready to re-enter with a payload and splash down. And then we got a couple more buttons. We got on buttons with the red chevrons. We hope we don't have to push any of these. One is the abort command, and that sends it away for about a day, and it gives us a chance to regroup and try it again. And then the command that we really don't want to send, and that's the FRGF set command. This basically separates the grapple pin from the vehicle if it's stuck on the end of the arm. And depending on what phase we happen to be, we might lose the contents of the vehicle if that were to happen. But at least it would save station from having Dragon permanently attached to it. So these are the commands that we have available as crew.
And Don, I apologize, that KU flip, I lost the top of that answer. I'm assuming from what you're saying is that all the way in, you guys have the ability to slow the thing down, stop the thing, send it away, whatever is required, depending on what the capsule is actually doing.
That's a good synopsis of what I just spent 5 minutes explaining.
You know, there doesn't seem to be a huge hurry for SpaceX or Orbital to get to station. I mean, you guys are fairly loaded with supplies and consumables right now. What's your understanding of when they really do need to start getting there? I guess what's prompting the question is it seems like there's a bit of a rush to get this off, and I don't know that I understand why there would be any need for a rush. It just doesn't seem to be an urgent issue right now.
The most important thing about this first attempt is to make sure you get your hardware, your software, and your operations down correctly. And they could send an empty vehicle up here from a supply point of view, and the important aspect is to show that we can actually do this. And the supplies are just frosting on the cake. However, we are on a frontier up here, and we're always on the verge of supply limited, and you can't just run down to the local grocery store. And just as an example, we're almost out of disinfectant wipes, and without that, we can't clean our hands after we go to the bathroom. And so we're always running low on things like that. We're getting low on garbage bag liners, and so we're looking at other things we can use to put our garbage in until we get more garbage bag liners. So there's always something that we're short on up here, and the more wagons bringing supplies to station, the better the supplies are here, and the better we can continue our work and get the business done of working and living in space and doing the research, the scientific and the engineering research.
Let me ask you, Andre, a question. Well, I may have this backwards. My understanding is, Don, you operate the arm for the initial capture, and Andre's on the CBM, I guess, and then it's backwards for deploy. Is that correct? And if it is, maybe Andre could tell us a little bit about releasing Dragon when its mission is over.
Actually, we look at ourselves as being a team, and we're sharing the flying duties, and it really doesn't matter who's flying the arm at what part in time. The important thing is that we work as a team both on station and with the scores of people on the ground that are also making this happen. And it isn't just us. It isn't just a person that happens to be touching the hand controllers at that moment in time. It's the whole team that transcends orbit all the way down to Earth.
I understand that, but I was just trying to give Andre a chance to tell me a little bit about Dragon. I was just wondering about the deploy sequence and how that works.
The deploy sequence, it's actually kind of mundane. We unbolt it from the side of station. Yeah. We pull it away about 1.5 meters, and then we type in an auto sequence on the arm, and it'll move it away to a good position for releasing Dragon. And then we open up the snares and carefully pull the arm back back a few meters, and then we punch one of the buttons that I showed you on that command panel, the retreat button, the depart button, and Dragon goes away. So it should be a pretty straightforward procedure for sending Dragon back home.
You know, one of the things that strikes me that Dragon really brings to the table, and you mentioned this in an earlier interview, is the ability to bring things back to Earth. How important is that, given that NASA has lost, you know, that great down capability the shuttle had? How important is that for station science?
Well, it's actually very important. You mentioned already if we would need it for supplies. Well, it's actually more needed to bring things back, because that capacity we don't capability we don't have anymore. So that's one of the most important things in my view, because, well, we have a lot of samples here that cannot return at the moment. Soyuz is a great spacecraft, but it's not a cargo spacecraft to bring back. And now we have this possibility, and we have a lot of samples, biological and physiological samples in our freezers here, and yeah, we're looking forward to bring that back to the planet.
Guys, thanks very much. I'm told we're about to leave
the fruits of most of our scientific labor are actual physical samples that need to be returned to Earth. And some of the science experiments just generate data in the form that can be sent back to Earth as radio waves. But most of the stuff that we do ends up with a tangible sample, and we need to get these samples back to Earth. And it's like the farmer bringing your crop to market. You can look at a picture of the crop, but you really don't get satisfied till you see the vegetable wagon pulling into the market.
Guys, thanks a lot. They tell me we're out of time. I appreciate it. Good luck with everything that's coming up, and hope to see you on the ground soon.
It's been good talking with you, and you all take care.
Station, this is Houston ACR. Thank you. That concludes the event.
Thank you, Fox News Radio and CBS News Station. We are now resuming operational audio communications.